First category is two-step equations. So over here, you of course have the watch help video and the show example, but I'll do one example with you guys. It's probably not the same problem that you have. I'll just say that now already. But this is just your example. So it's a two-step equation, so that means you should be able to solve for C in 2 steps. So we have 8 is equal to negative 3C plus 29. If I want C by itself, I first get rid of the 29. So I'm going to subtract 29 because the opposite of adding is subtracting. So I subtract 29 from both sides. I'm going to rewrite this answer over here. So 8 minus 29 will be negative 21. Negative 3C, I'm just going to bring it straight down. And then the plus 29 and the minus 29 cancel out. So we're ending up with negative 21 is equal to negative 3C. That was our first step. Remember, this is a two-step equation, so there's one more step. C is being multiplied to negative 3. Whenever a number and a letter are right next to each other and there's no symbol in between there, that is multiplication. And how do you get rid of multiplying? You divide. I'm going to divide by negative 3. Divide by negative 3. That will cancel out with this, and we'll be left with C finally. And then negative 21 divided by negative 3 is positive 7. Negative divided by a negative is a positive. Of course, if you need to use a calculator, feel free to do so. But the answer for my example is 7. Now, your situation will probably look different because we have different problems on Delta Math, but here's just your example. Write it down or take a picture of it, however you need to use it for your notes because the final is open notes. Okay, submit. Cool, so that was our first example, and I'm only going to do one example of each because remember, you also have the watch help videos and the show examples, and technically you have my old videos from like all the old on my website. So we only have limited time, so I'm just going to do one example of each type. This is a 3-step linear equation, so as you can probably guess, there are 3 steps to this. So let me just copy this out right here just to give me more space. Okay, so my first step would be to bring all the x's to the same side. So we have a negative 6x here and a negative 10x here. I'm just going to add 10x so that my x's are together. Sounds kind of weird, but yeah. Then this will cancel out. We will just be left with negative 20 on the right side. And then on the left side, we have negative 6x plus 10x. That gives you positive 4x. And that is our first step. Our first step was just to move all the x's to the same side. And I just chose to move the 10 because I want it to be a positive x, but it doesn't matter. If you chose to move the 6x, that would have been fine too. Like, it literally doesn't matter. You will still end up with the same answer. So that was our first step. The next step is to bring the 8 to the other side because you remember you want x by itself. So minus 8. Those get to cancel out because adding 8 and subtracting 8 are opposites. We are left with 4x over here is equal to negative 20 minus 8 is negative 28. After that, x is being multiplied to 4. Remember, if there is no symbol in between the 4 and the x, it's just 4x. If there's no symbol, that means they're multiplied. So how do you get rid of multiplying? It's the opposite of multiplying. It's dividing. So I'm going to divide by 4 on both sides. That can cancel out. I'm just going to write it to the side. X can equal negative 28 divided by 4 is negative 7. So my final answer for this one is negative 7. Okay, any questions for this one? Okay, so it's lagging, but you notice it says 0 out of 2. For the 3-step linear equations, now it says 1 out of 2, so we know we got it right. Let me clear the screen, and then I'll just move on. Okay, so we've got those 2 examples done. Let's do linear inequality and number line. Okay, solve the inequality and graph the solution on the line provided. So we just need to get x by itself. It's pretty much just like the equations we did earlier. So I'm going to add 17 because I want x by itself. Those will cancel out. We will get 4x is less than or equal to Negative 32. And of course, if you need a calculator, like I almost did, feel free to use a calculator. Sometimes it's just early in the morning and your brain needs time to wake up, so it's okay to use a calculator. Okay, so I'm just gonna rewrite this over here so I don't block that box. All right, so now x is being multiplied by 4, so we get rid of that by dividing by 4. Those cancel out. X is less than or equal to negative 8. So when you divide or multiply by a positive number, you keep your sign the same. But it might be the case that you have to divide or multiply by a negative number. So I'm just going to remind you that if you divide, multiply by a negative, flip the sign. Just a little reminder. So for example, if I have negative 2x equals 6, less than or equal to 6, if I divide by negative 2, x will then be greater than or equal to negative 3. Notice the sign has flipped from a less than or equal to a greater than or equal to. So that's just a little quick example about if you divide or multiply by a negative, you must flip the sign. So my example right here, I ended up with x is less than or equal to negative 8. I didn't have to flip my sign, see? Because I only divided by a positive 4. So I did not flip my sign. But if you divide or multiply by a negative, you must flip your sign. So then I type that x is less than or equal to negative 8 right over here. And then we just click and drag to plot the line. Here's negative 8. And then I'm going to just drag it all the way to the left because less is numbers like negative 9, negative 10, negative 11, and negative 12. It's all the stuff to the left side. Less is left. Both of that starts with L if you can't remember. Less is left. And then finally, I like that this is a closed circle because this is less than or equal to. So that underlined over here, that tells me I want a closed circle. Closed circle, open, 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 close, close. Any questions? Okay, and then clear all that. Okay, so we did 3 examples. Let's do standard to slope intercept form. By the way, we probably won't get through all the examples today, but that's why we also have Tuesday, right? So don't worry if we don't go through all the examples. This is just to remind you how we did stuff from like January, February, March, because you probably wouldn't remember. And if you do, great job. Put the following equation of a line into slope-intercept form. That is y equals mx plus b form. Simplifying all fractions. Okay, so in y equals mx plus b, that just means you really want your y by itself. So that means I want this guy by itself. So let's move it around so that we can get that. Let me rewrite the equation so we have more space. Okay, so if we want y by itself, the 3x is in the way. This is a positive 3x, so I'm going to subtract 3x to the other side so that it just moves to the right side. Those cancel out. We get negative y is equal to negative 3x plus 1. Okay, so we're really close, but remember in y equals mx plus b, y is positive, and we don't want a negative y over here. So what I'm going to do is multiply everything by negative 1. So that flips the signs, essentially. I'm just going to flip the signs. So y positive now is equal to positive 3x. Now it's a minus 1. And then we're good to go. Y is equal to 3x minus 1. And you want to type the entire equation. I don't want to just type 3x minus 1. This is going to be wrong. We are putting this in slope-intercept form, which is an equation. Equations must have the equal sign, so that's why I must have y equals. So y equals 3x minus 1. Any questions for this one? All right, let's go to the next category. Compound inequalities right here. Okay, solve for x and graph the solution on the number line below. So let me write this out again because space. Okay, so I just rewrote it. Now let's get x by itself. So I know there's 3 parts to it. Normally in equations, you guys are used to just having 2 parts, but that's totally fine. You're going to treat this the same way. If you want x by itself, you're going to get rid of that 5 first. So I'm going to subtract 5. But I'm going to subtract 5 from every side. Normally it's just 2 sides, but now we have 3 sides, but you still treat it the same way. So subtract 5, subtract 5, subtract 5. This will cancel out. You will have negative 2x left in the middle. The signs just stay the same right now because we didn't multiply or add by a negative. So, sorry, multiply or divide by a negative would flip the signs. But since we just subtracted 5, the signs stay the same. 19 minus 5 is 14. 11 minus 5 is 6. So far, this is what we have. All we did was subtract 5 from all 3 sides. Next, we have x multiplied by negative 2. So the opposite of multiplying would be dividing. I'm going to divide by negative 2 on every single side. So divide by negative 2, divide by negative 2, and divide by negative 2. But remember, when you divide by negative 2, the signs have to flip. So instead of a greater than or equal to, it's a less than or equal to. So they flip now. Because I divided by a negative, I must flip the sign. That greater than becomes a less than. Notice that they are flipping because I divided by a negative. And then 14 divided by negative 2 is negative 7. 6 divided by negative 2 is negative 3. So this is our final answer. Okay, so any questions up till here before I do the number line portion? Let's type this in then. So we have negative 7 is less than or equal to x, which is less than negative 3. So when you have the x's in the middle, that means you're going to have, here, let me just graph it for you first. Here's negative 7. Here's negative 3. So that means you're going to go between the negative 7 and the negative 3. Here's the negative 7, here's the negative 3, and I've shaded everything in between because x is literally in between the negative 7 and the negative 3. When you write it out, x is literally in between. So therefore, I'm going to shade in all the in-betweens. Now, there's one more thing I have to change on this, and it's one of the circles. One of the circles must be an open circle. Remember that this is open symbol, open circle, closed circle, closed circle. So at the negative 7, it should be closed. So this is good. At the negative 3, this is a less than. There's no underline here. Because there's no underline, it must be an open circle. So I'm going to click closed circle to change to open circle. And there we go. And so this is our final answer. So any questions on this one? All right. So we did 1, 2, 3, 4, 5. Okay, let's do substitution level 3. Okay, so we're gonna do solving the system by substitution. So hopefully you guys remember this. If not, that's why we're going over it. So when you substitute something, you're gonna look for which variable is by itself. X is by itself. So you can think of substitution as replacing, and you can also think of it maybe in terms of having a sub-teacher. So pretend that this is me. I am your teacher. And this is the substitute teacher, okay, the negative 5x minus 10. And this is me in my classroom. So this is a x plus 9y. I'm just going to write it out. This is me in my classroom. Me in my classroom. But sometimes the teacher has to be gone, right? So then you're going to replace the teacher, me, with the substitute teacher. Because we're equivalent. Like there's a substitute teacher is totally fine. So I'm going to take the substitute teacher and put it in the classroom. So instead of this x here, which was me, you're going to put the negative 5y minus 10. That's the substitute teacher. And you're going to put it in the classroom. So plus 9y equals negative 2. So literally all I did was I took me and I replaced it with a sub teacher. Took the x and replaced it with this thing that x is equal to. Okay, so once you do that, then you'll notice that there's no more x in the equation, it's just y. That means you can solve for y. So let's do that. We have negative 5y minus 10 plus 9y equals negative 2. So I can actually combine the negative 5y and the plus 9y. They're on the same side of the equation. So literally, what is negative 5y plus 9y? And that would give us positive 4y. And then minus 10 equals negative 2. And so now that we've kind of condensed it together, we can solve for y. Just get it by itself. I'm going to add 10. That cancels out. We get 12 over here for y equals 12. Then y is being multiplied by 4, so I'm going to divide by 4, because dividing and multiplying cancel out. Then that gives us y equals 3. So you will notice that there are 2 boxes over here in our answer. This is your x, this is your y. Remember, the point is always x comma y. X comes first, y comes second, but you need both values to submit your answer. I could type my 3 in right now, but I still need to find my y. My x. Are there any questions up until here? So remember, we have our y, but we need our x. We're not done yet. So the easiest way to solve for the x is, let me just point to it, this equation, because it literally says, let me just write it out in a different color. It says negative 5y minus 10 equals x. X is already by itself in this equation, so that would be the easiest equation to get x, because it's already solved for x. So I'm just going to plug in y into this equation. So negative 5y minus 10 equals x. So all I did was plug in the y value that we solved for. So negative 5 times 3 gives us negative 15. And then negative 15 minus 10 is negative 25. And x is already by itself, so we now know negative 25 is equal to x. X is equal to negative 25. I can just type it in over here. Okay, any questions on this one? Oops, my answer is not correct. Oops, let's fix that. Let's see. What did we do wrong? All right, let's figure this out, because we gotta figure out the mistake. So x plus 9y equals negative 2, negative 5y minus 10. Plus 9y equals negative 2. Oh, okay, negative 2 plus 10 is not 12. Silly Miss Jade. Okay, let's do that. Let me use my eraser. Negative 2 plus 10 is 8. Okay, so let's fix that right over here. I need to click more buttons. Let's fix it in purple. Negative 2 plus 10 equals 8. There we go. And then so finally 8 divided by 4 gives us 2. My bad. Okay, so if y is equal to 2, then that's the number I want to be plugging in. So I'm going to erase this 3 because that was our mistake, right? And instead of plugging in 3, I want to be plugging in 2 because 2 is our y value. And then when we plug that in, let me erase all of this. And then let's actually calculate our new y value. So negative 5 times 2 is negative 10. And just write out the rest of the equation. Negative 10 minus 10 is negative 20. We get negative 20 equals x. So there we go. My bad. That's why we got 2 attempts, right? So that if you make a mistake on the first one, you can correct it on the second one. And this is also why you write out all your work, so that if you make a mistake, you can go back, find your mistake, and correct it. Okay, so any questions on this one? Resume recording, submit. There we go. Let's go to another one. So elimination guided. So we did substitution. Now we're on to elimination. Let me clear the screen. Okay, feels so much better. All right, we're going to solve the system of equations. X plus 2y equals negative 20. That's this one. And x plus 3y equals negative 27, that's this one, by combining the equations. So if you don't remember elimination, that's where you want opposite but equal either x values or y values so that they can cancel each other out. So for example, here, it would be a lot easier for us to cancel out the x's because this is 1x and this is 1x already. The only thing we need is for one of them to be the opposite symbol. We need one of them to be negative. Now it doesn't matter which one you do, top or bottom. I'll just do this one. So I'm going to multiply this top equation by negative 1. And notice negative 1 times x gives you negative x. Negative 1 times 2y gives you negative 2y. Negative 1 times negative 20 gives you positive 20. So I just multiplied the entire first equation by negative 1 to get this one. And the bottom equation just remains the same. And finally, we did that because we want x and negative x to be having the same coefficient, but opposite signs. So negative x and positive x. When you have it this way, negative x plus positive x will give you 0x. And then we can add this one straight down as well. Negative 2y plus 3y gives you 1y. And positive 20 minus 27 gives you negative 7. So then I'm going to press try. It won't let you finish it if it was wrong. So if it moves on, then you're good. Then it says solve for y. Y is already equal to negative 7. So then you just type negative 7, you press try. And then that means we got our negative 7. That was correct. We plug it in to either equation to solve for x. So it doesn't matter which equation you choose, you just choose one. I'll choose this one just because it's written first. And then I'm going to plug this in over here. So instead of 2y, it's 2 negative 7. So just plug it in. And then we get x minus 14 equals negative 20. Then to get x, we just add 14. So that's a 14. Cancels out. X will equal to negative 6. So then I'm going to press try after I type it in. And if it's wrong, it won't let me finish. But looks like it was correct. If it wouldn't let me finish, then you just need to go back and fix it yourself. Final solution, remember that it's x first and then y. So our x was negative 6. Our y was negative 7. And then I'm going to press try. And it lets me have the submit answer button, which means we are definitely guaranteed to be correct. So before I submit that, are there any questions? Okay, 1, 2, 3, 4, 5, 6, 7. How many problems are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24. Okay, so it's 23-ish, whatever. I'll do half of the problems today, so we'll just keep going until there's half, and then that way we'll save some for next class, and you're not going to be too annoyed at listening to my voice the entire day. Okay, let's go to determine number of solutions in system. Okay, determine if the following system of equations has no solutions, infinitely many solutions, or exactly one solution, not student. Okay, so essentially you're just going to solve for x or solve for y, and no solutions would be if it tells you a lie, like it says something like 3 equals 4 or 5 equals negative 1. Like it says something that just doesn't make any sense, like 1 equals or 0 equals 2. That's like a straight up lie. That would be the no solutions. Infinitely many solutions is if it tells you something that's so obviously true, like 3 equals 3, 5 equals 5, 0 equals 0. You're like, well, duh, yeah, that doesn't tell me any new information. That means there would be infinitely many solutions. Exactly one solution is if you get x equals a number, or if you get y equals a number. And there's going to be one solution. So that's pretty much the idea behind this one. So let's solve for it. I'm just going to do this in a different color now. We got 2x plus y equals 3 and negative 4x minus 2y equals negative 5. I don't see x or y by itself. So that tells me that I think elimination method would be better. So I'm going to change this equation by multiplying it by -2. And I'm just focusing in on getting rid of the y's. You can get rid of the x's, it doesn't matter. But I just looked at the y's and I was like, oh, I want to eliminate the y's. And I'm going to do that by multiplying it, actually by +2. So that way, I will have a +2y, and then that can help me cancel with the -2y. So let me rewrite it. 2 times 2x gives me 4x. 2 times y gives me 2y. And then 2 times 3 gives me 6. So all I did was distribute the 2 that I wanted to multiply. Just distribute it to the entire equation. And I'm just going to write the other equation underneath. I haven't changed it. Okay, so now I'm going to add these together. So 4x minus 4x. Oh, that cancels. So that's a 0. 2y minus 2y. Okay, that also canceled. That was my intention. I wanted my y's to cancel. So I got 0 plus 0 is equal to 6 minus 5. That's going to be 1. So in conclusion, we got 0 on the left side equals 1 on the right side. And that is a straight up lie. So we have no solutions. 0 is not equal to 1. So you just can't have that. Are there any questions on this problem? Okay, let's clear that annotation because it's messy. And then let's solve linear system graphically, level 1. Solve the following system of equations graphically on the set of axes below. So I'm just going to scroll here so I can see this. These are in the format y equals mx plus b, where m is your slope. Remember that? Slope is rise over run. And then this b is your y-intercept. Okay, so let's start with our first equation, -x plus 3. We have a y-intercept of 3. It's the number that's added or subtracted at the end. So I have 3, so I'm going to click on the 3 over here. Now we deal with the slope. So the slope is negative, -1 specifically. So -1, I'm just going to write it. -1 looks like a whole number, but we like it in fraction form. So to get it in fraction form, if it's a whole number, it's just over 1. So a -1 for your rise means you're going to go down 1 from your y-intercept, down 1. And then a +1 run means you're going to go right 1. So I'm going to go down 1, right 1. And I can just click here. And this is our first line. Let's take a look at our second equation. So we have a y-intercept of -2. So I'm going to start over here at the -2. And from that -2, we're going to go rise 3, and run 2. That means I'm going to go up 1, 2, 3, and I'm going to run 2 to the right. And so these are my equations. Before we move on, are there any questions about how to graph these? Okay, so then we need to select the solution. So the solution is literally just the intersection point. So you want to read it from the x-axis first, and then you read it off of the y-axis. So this is 2, 1. Type it with parentheses, because that's how you type a coordinate point. You must type it with the parentheses. So the answer is 2, 1. And it's just the intersection point. It's where they meet. Okay, let's do right system of equations from context. So we're getting more and more recent, so hopefully that's a little bit better. So for this problem, it says Sophia and London work at a dry cleaner's ironing shirts. Sophia can iron 40 shirts per hour and London can iron 25 shirts per hour. Sophia and London worked at a combined 11 hours and ironed 365 shirts. Write a system of equations that could be used to determine the hours Sophia worked and the number of hours London worked. Define the variables that you use to write the system. So we're searching for the number of hours Sophia worked and the number of hours London worked. These are going to be your variables. So I'm going to have not number of shirts. Nope, because we want number of hours. So number of hours, and not the rate, because we want the number of hours. So I'm going to click number of hours, and I'm just going to use S and L because that just makes sense to me. S for Sophia, L for London, but it's representing the number of hours because that's what we want to determine. Determine the number of hours, okay? So that's how you define your variables. And then let's go back here. Sophia can iron 40 shirts per hour and London can iron 25 shirts per hour. Sophia and London worked a combined 11 hours and ironed 365 shirts. So if you add the number of hours Sophia worked, S, plus the number of hours London worked, this is the number of hours they worked in total. They worked a combined 11 hours. Oops. So S plus L should equal 11. And then let's take a look at this one. Sophia can iron 40 shirts per hour. So 40 per hour for Sophia, 40 per hour for Sophia. And then London can iron 25 shirts per hour. So 25 shirts for London. So if you add that together, they've ironed a total of 365 shirts. Equals 365. All right, so are there any questions on this example? I know this one's a lot to write, so maybe you guys could take a picture of it as your example instead of just writing it out, but any questions? And then let's do another one. So write single inequality from context. Okay, so Peyton has N nickels and D dimes. She has no less than 21 coins altogether. Write this situation as an inequality. So no less than 21 coins. So the total coins will be N, that's not N, N plus D, so nickels plus dimes. That should be no less than 21. That means not less than. That means greater than or equal to. N plus D is greater than or equal to 21. Because it's no less. So it's not less. So you want greater than or equal to. Okay. So it means 21 or more if it's no less. So we use greater than or equal to. Let's see. Let's graph linear inequalities. Graph the inequality on the axes below. So this is kind of like y equals mx plus b form, and we're going to treat it like that for now. So you're going to start off with your y-intercepts at 2, and then we have a slope of -1. So a slope of -1 is a -1 over 1. Let me write that out. So it's a rise of -1 and a run of 1. That means we go down 1 and run right 1. So this is our line for this equation, but this says greater than. So if you say greater than and there's no underlining, I want this to be a dotted line. Remember that this is going to be dotted, but if it has an underline, then I want it to be solid. Right now it's solid, so I'm going to click change line. So now it's dotted. So if you don't see the underline here, no equal to line, then you want a dotted line. And then you also want to see if you want to shade up or shade down. So you look at it, what it says y is greater than, that means you want to shade up. So there we go. And so you can click shade to like determine which side you want to shade. I want to shade up. So if you just put your, imaginary mouse or finger or your eyeball, whatever you want to put on the line, you just go upwards. That is the direction you want to shade. Because I know some people are like, but this looks like it's to the right. I'm literally saying if you take a point on here and you just go upwards, you see this is a section that I am shading. Even though it is also to the right, it is also upwards. It's both up and right. So y is greater than, then you want to shade up. So let me just clarify for you. This and this is dotted. This is solid. And then also this one, this is like y is less than. If you have y in the front, this is how you want to read it. Y is in the front. If it says y is less than, then you shade down. Y is greater than, you shade up. Y is less than or equal to, you shade down with a solid. Y is greater than or equal to, you shade up with a solid. Okay. Any questions on this one? Oh, wait, I have to submit it. I almost just like forgot to submit it. Okay. And let's see, where are we at? Graphing linear inequalities. Okay, now linear inequality systems graphically. So it's essentially what we just did, but twice. And then we just pick a solution. So let's do this twice. We have y is greater than negative x plus 2. That's the same equation we just did. So 2 is your y-intercept. Negative x means the slope of negative 1. So down 1, right 1. And I want this to be a dotted line. And I want to be shading up. Dotted because there's no underline here. And up because it says y is greater than. Next equation, it says y is less than or equal to 1/2 x minus 4. So minus 4 is your y-intercept. This is your slope, so it's rise of 1, run of 2. So I'm going to go up 1, right 2. So that's my line. It says less than, no underline, so I want this to be dotted. And it says y is less than, so I want to shade down. So this is what it, oh, I guess I could show the equations too. This is what it looks like. Are there any questions until here? So from here, we still need to choose a point of the solution. So you literally can pick anything in this double shaded region. So let me pick a few points. This one is only shaded once, so you don't want to choose anything here. This side, this section is only shaded once, you don't want to choose here. This section is not shaded at all, you definitely don't want to choose anything here. But in this section, you can choose anything. So for example, I could have chosen this point, which is 9, negative 1. I could choose this point, which is 9, negative 5. I could choose this point, which is like 8, negative 3. I could choose this point, which is like 6, negative 2. Hopefully you get the point. You can choose any point in this section, okay? So I'm just going to choose, I don't know, 6, negative 2, whatever. Doesn't matter. You can choose any point. And then you just submit it. So choose any point in the double shaded region and you will be good to go. Okay, so let me clear those annotations. Wait, where are we? Okay, context inequality systems graphically. So Alexa and her children went into a movie theater where they sell bags of popcorn for $8 each and pretzels for $5 each. Alexa has $45 to spend and must buy a minimum of 6 bags of popcorn and pretzels altogether. If X represents the number of bags of popcorn purchased and Y represents the number of pretzels purchased, write and solve a system of linear inequalities graphically and determine one possible solution. Okay, so essentially, let's write out our equations. I'm going to do this in annotations first. So X is the number of bags of popcorn and Y represents the number of pretzels purchased. So that's something we need to keep in mind. Let's see. Okay. They sell bags of popcorn for $8 each and pretzels for $5 each. I guess I should start underlining from there. Okay, so X is popcorn. So I'm going to write 8X for representing that popcorns cost $8. And then pretzels are Y, so I'm going to write 5Y to represent that pretzels cost $5. And Alexa has $45 to spend, so she can spend less than or equal to 45. She cannot spend more than 45, but she can spend less than 45. She can spend exactly 45, but she cannot spend more. So therefore, it's less than or equal to 45. Then there's also, what color should I use? I'll use this one. Must buy a minimum of 6 bags of popcorn and pretzels altogether. So bags of popcorn and pretzels altogether would be X plus Y. And she wants a minimum of 6. So minimum means you can be greater than 6 or you can be equal to 6. So x plus y is greater than or equal to 6. So here are our two equations, but we just need to get them in slope-intercept form. Just notice that over here we have y by itself. So that's just slope-intercept form. Oh, I should not have written them next to each other. Give me a second. There you go. Just gonna move that over there. Okay, cool. So now that we have our two equations, let's change them into slope-intercept form by getting y by itself. So if we're dealing with a purple equation, if I just subtract x, those cancel out, I get y is greater than or equal to negative x plus 6. Now y is by itself, and I can type that in here. Y is greater than or equal to negative x plus 6. And I can click plot. Okay, I will switch to shade later, but for now, just let me write that in there, because once I scroll, you're not going to see that. Let's do our red equation. So remember, we want y by itself. So I'm going to subtract 8x. Those cancel out. We get 5y is less than or equal to negative 8x plus 45. Then you're just going to divide by 5 for everything. Those cancel out. Y is less than or equal to negative 8 over 5. Just leave it as a fraction. Fractions are great. X plus 45 divided by 5 is 9. So I got the negative 8 over 5 by literally dividing those two as a fraction. And then plus 9 I got by dividing 45 by 5 as a fraction. So let me go ahead and type that in. Y is less than or equal to negative 8 over 5 x plus 9. And then I'll click plot. You can't see it yet, it's down there, but before I scroll down, and then we'll just kind of lose sight of all the words, before I do that, are there any questions up till here? So as you can see, here are our graphs. So for this y is greater than or equal to negative x plus 6, that's going to be that line that's getting the shading right now. So if it's y is greater than or equal to, I want to be shading up. So that's why I'm going to click up to shade it up. For the next one, it says y is less than or equal to. So that's this line. And so if it says less than or equal to, I want to be shading down. Finally, we just choose a point in the double shaded area. So that double shaded area would be anywhere in this section. So you can choose any point there, as long as it's in that section. Well, and I guess as long as it's a whole number, because you can't buy like a 0.5 bag of a pretzel, okay? So you can choose this point or this point, sorry, hard to, there, that point, or you can choose that point. Let's just choose 1,7 because I like to have a lot of bags of snacks. So 1 bag of popcorn and 7 bags of pretzels. So 1,7. And just to make sure, 1 bag of popcorn, 1 should be our x. So let me just make sure popcorn was x. Yes, x represents the bags of popcorn. So we're good to go. I didn't mix it up. Just double checking that x represented the bags of popcorn because this x was 1. So 1 and 7. And yeah, so let's submit this one. And let's do another. Wait, actually, let me see. Okay, yeah, so that's where we will stop for today. And then on Tuesday, we will resume with the exponent stuff. And in that way, even if we get here and we don't get to do examples of these, we just did examples of those in like the last review video. So I'll put that up on the website as well.